Last time we found out how to convert base 2 into base 10, or binary to decimal. Now we're going to find out how to convert base 10 into base 2. Just moving my chair over here. So first, let's use a small number as our example, in decimal, of course. Let's say 74. So I want to get a color. 74. The first question you ask when converting decimal to binary is, what is the greatest power of 2 that is less than this number? So in our case, that would be 64, because the next power of 2 is 128, and that's greater than 74. So let's say put 64 is less than 74, but that's less than 128. So we use 64 here. So now, since 64 is 2 to the 6th, so this is 2 to the 6th, there are going to be 7 digits in our number. So remember how place value for binary used powers of 2, starting with 2 to the 0th? So 2 to the 6th will be our last power, so that means that there are 7 digits between 2 to the 0th and 2 to the 6th. So now we look at the difference between 74 and 64. 74 minus 64 is 10. So let's write that down. We could use a completely different color. 74 minus 64 equals 10. So now we know we need to make 10 with powers of 2, and then we're done. So now we do the same thing as here. We take the biggest power of 2, which is smaller than 10, which would be 8. So 10 is less than 8 is less than 16. So we add 8 to our equation, so all that's remaining is 10 minus 8, which is 2. And all we have left is another power of 2, so we just add our 2 to the equation. And now we're done, because 2 plus 8 plus 64 is 74. So now we can figure out the base 2 version of 74 now. So we can do the off-on thing again. So we'll get, let me draw the buttons again. Let's see. So we're going to need 7 buttons. 3, 4, 5, 6, 7, and then, so what are we going to get? We're going to get 64. So the first digit of any binary number is always going to be on. Just want to point that out. And then off on. This would be 8 on, and then this would be 2 on. So on, off, off, on, off, on, off. I think that I said that right. So the last step is simple. We just convert our ons and offs to ones and zeros, and so we get, I'm going to use the same color as this, so we get 1 0 0 1 0 1 0 in base 2. Yay, so these two are the same. Equals. So let's take a bigger number. Let's say, let's make some space here. Okay, let's take a bigger number now. So 3,815. So now I'll let you try to figure out what this number is in base 2. So I'll give you a little time to pause the video. Okay, so hopefully you paused the video and you tried to figure it out. Now let's see how we can do this. So first of all, let's see, what is the smallest power of 2 less than 2,815. That would be 2,048, because the next biggest power is, I'm using colors here, but it's fine. The next biggest power is 4,096. So, want to use this. So, since this is 2 to the 11th, we're going to have 12 digits in our number. So now we find the difference. So, let's see, what is the difference of these two? Let's see, 2,815 minus 2,048, that's 1,767. So, why don't we just write all of them down here? So, 2,048 plus, so this is enough to fit 1,024 in. Then if we subtract 1,024, we can get 743. So we'll get 512. I almost put the wrong thing there. So minus 512, we get 231. So that is 128. Then this minus 128 would equal 103. So we add 64. And then our next difference, minus 64, is 39, so that's enough to put 32 in. So minus 32, then we just have 7, so that would be 4 plus 2 plus 1. So now we can, I'm not going to do the buttons here because there are a lot of buttons, so we just can convert this into, let's use pink again. So this goes into, let's see, 1, 1, 1, 0, because we skipped the 256 here, then 1, 1, 1, then no 16, no 8, and then 1, 1, 1, 2. So these two are the same. So I may go over other bases in the future. Maybe base 16, or 8, or 3. I'll figure out which one of these to do. Or maybe I'll do all of them. We'll see in the future. So, hopefully this helped you out. See you guys next time.